Hey guys, so here is part 2 of the 7.6 day 2 notes. We're once again solving logarithmic equations. Okay, so if you notice on the past 4 examples, our logarithm was always isolated. So either if you have a log equals a log, just automatically set what's in the parentheses equal to each other. If you have a log equals a number, you do need to make sure that your log is isolated. So like here on number 5, we have 5 times log of x plus 2 equals 12. Well, our log of x is not isolated. Okay, so we need to isolate it, so we have log equals a number. So in order to do that, and I'm just going to rewrite this, this is where we're going to, of course, like a multi-step equation, add or subtract or multiply or divide anything and move it all over to the other side. So the first thing I notice is I need to subtract 2 from both sides. So that 5 times log of x equals 10. Now I notice I have the 5 in front of my log of x, so I'm going to divide both sides by 5. So now 10 divided by 5 gives me 2. Now that I have a log equals a number, I can go ahead and rewrite in exponential form. Okay? Now, if you notice, you might not see a base on this log. Well, remember, when you don't see a base, that is our common log, and so it's assumed that the base is 10. So don't forget that about your common log. Okay, so now I'm going to rewrite it. So 10 is my base on the log, so it's going to be the base on my exponential. 2 is the exponent, and then x is just the y value. That's what we're solving for, okay? So when I calculate that 10 squared, that gives us 100, and that's my final answer. Okay. Okay, let's go ahead and do the next one. So for 6, we have log of 2x plus log of x minus 5 equals 2. Now, this doesn't look like what we've done before, right? We don't have a log equals a log, and then we don't have just a log equals a number. So we have to manipulate this a little bit, so we do either or. Well, we're not really going to have a log equals another log, because we have that number 2 on the right-hand side. Instead, we're going to be using our log properties to condense so that we can get it into where it's a log equals a number. So, to condense, remember, notice we have the product property, meaning I see an addition, and to condense, it's going to be multiplication. So now I have log of, I'm going to do it this way, 2x times x minus 5. Okay. Now let's go ahead, I'm going to multiply the 2x by the x and minus 5. So I have log of 2x squared minus 10x. Okay, now I'm going to go ahead and rewrite in exponential form. Now, if I look at this log, once again, I don't see a base. If you do not see a base, what is that? That's going to be 10. Remember, that's always the common log, and the base will always be 10 when you don't see it. Okay, so since the base on our log is 10, that's going to be the base on our exponent. 2 is going to be the exponent itself, and then 2x squared minus 10x is the answer. Okay, so now I evaluate, of course, 10 squared, which we get 100. Now, you might notice here, oh, I see a quadratic because I have an x squared. And that means this is a quadratic equation. Well, what are the ways to solve a quadratic equation? Well, remember, this is where we can either factor, complete the square, take the square root on both sides, or quadratic formula. Well, I don't think we should do completing the square. I say never use that. And we do have our middle term of the negative 10x, so we can't really take the square root on both sides. So instead, we can either factor or do the quadratic formula. Now, if we do either of those, we do have to set our equation equal to 0 to do that. So I'm going to move the 100 over, so I have 0 equals 2x squared minus 10x minus 100. Now I'm going to see if this is factorable, because I think that's always easier to do than trying to do the quadratic formula. Now if I am factoring, notice we see that our a value is something other than 1. So whenever that happens, we first have to figure out, do the terms have anything in common we can take out? Well, in fact, these three terms do have a 2 in common, because 2 can go into 2, 2 can go into 10, and 2 can go into 100. Now, none of them have a variable in common because our last term of 100 does not have the x, so we can't take that out. So I'm only going to take a 2 out and rewrite my expression here. So when I do 2 divided by 2, I'm left with x squared. Negative 10 divided by 2 leaves me negative 5x, and negative 100 divided by 2 gives me negative 50. Now I go ahead and do my 2 sets of parentheses. And remember, we figure out what numbers multiply to 50 and can add up to the 5. Well, let's list all the numbers that multiply to 50. We got 1 and 50, 2 and 25, no 3, I don't think no 4, 5 and 10, and I think that's about it. So, rewriting this, my 2 sets of parentheses, I do x and x, and the reason I do that is now the a value in front of my x squared is a 1, so I can automatically do x and x. Well, the only pair I can see that will work to add up or subtract to the negative 5x is 5 and 10. Now, to subtract to that negative 5x, I need to have a negative 10 and a positive 5. Now, I set my factors equal to 0 and solve. Remember, what's in the parentheses, these are our factors because they have the variable. The 2 is not a factor. And so we are not going to set it equal to 0, because if we try to do 2 equals 0, does that work? No, that doesn't make sense. So now I have my x plus 5 equals 0, and then x minus 10 equals 0. So now I have x equals negative 5 and x equals 10. Now, before I box or circle this, what I need to do is check for extraneous solutions. Ooh, that word came back again. So we've kind of talked about extraneous solutions, okay? We've talked about it in absolute value functions. We've talked about it, we didn't really do it in the radicals, but you could get extraneous solutions there, and there were some other areas where we could talk about extraneous solutions. Now remember, what are extraneous solutions? These are solutions that if we plug it back into the original equation, it does not work, okay? So, how do we know if for our logarithm the number doesn't work? Well, this is what we need to do. If you get a negative number inside the parentheses, of a log, that means the value is extraneous. Because this is what we need to talk about, okay? Let's say I plug in a negative, and I'm just going to use the common log because it's easier. Let's say I do log of negative 2. Let's see what happens here. We get a non-real answer. We get an error. So anytime we get a negative number inside the parentheses of any log or natural log, it will not work, okay? Meaning if we take our numbers, our x values, plug it back into what's inside the parentheses, and we evaluate and we get a negative number, that value does not work, okay? Now, we actually have to check this for all logarithmic equations. Now, notice we didn't do it in the last one, so we're going to kind of go back to those and talk about it as well. Okay, so we are going to try -5. We're going to plug that back into the original logarithmic equation up here and see, do we get any negatives when we evaluate negative numbers inside our parentheses? And then we'll do the same thing for our 10 as well. Okay, let me come back down here. Okay, I'm going to do the check in a different color so we know. I'm going to bring it up here. Okay, let's try x equals -5. So the original was, we got log of, and now the 2x is in parentheses, okay? Then plus log of -5 minus 5 equals 2. So let's check this. So when I evaluate, I get log 2 times -5, that gives me -10, and then plus log of -10. Oh, we get negative numbers. So that means x equals -5, that is extraneous, because when we evaluate it in our original equation, we get negative numbers. So that doesn't work. Okay, let's try x equals 10. So I'm going to do the same thing. I have log of 2 times 10, and for any place I see x, that's where I'm plugging in my 10. And then I think we had 10 minus 5, so it's x minus 5 equals 2. Okay, so then I get log of 20, that checks out, plus log of 5, that checks out, because both are positive. So that means x equals 10 is a solution, okay? Okay, but let's kind of check some of these other ones that we didn't. So like when we get x equals 100, let's see if that works. So if I plug it back into just my original equation where I see x, well, log of 100, that's positive. So x equals 100 was a solution, so that worked out. Okay, what about our 38? Well, we kind of did a check, right? When we did 38 minus 6, I got 32. Is 32 positive? Yes. So x equals 38 is a solution. What if when I plugged x equals 13? Well, when we evaluated that, I got log base 4 of 64. That is a positive number, so that worked out. We didn't even have to do it here. Okay, so when I plugged x equals 4 into our parentheses, on both sides I get a positive 9. So that means 4 worked. And then what about when I did x equals 3? Well, when I evaluated inside the parentheses, I got 17, positive 17 on both sides, so that worked. So for all your logarithmic equations, you might want to write this onto your notes. I'm going to put that here. For all logarithmic equations, you need to check for extraneous solutions. Okay? So just make sure you do that when you do these logarithmic problems on your homework. Okay? Okay, guys, make sure you guys work on your homework assignment, and if you have any questions over this, make sure you contact me. I'll see you guys later.